Good day, students. On this clip, we're going to be going over how to graph parent sine and cosine functions. Before we go ahead and get started, we're going to look at the equations, the transformational forms of the sine and cosine function, okay? So let's write it down, transformational forms. Transformational forms. All right. So it's very similar for the sine and cosine. Let's look at the sine first. So for the sine, we have y minus k equals a bracket sine parenthesis a sine b parenthesis x minus h. Okay, so this goes the transformational form for sine, and then for cosine we have y minus k, same thing, equals a times cosine b parenthesis x minus h. Okay. Alright, so what do h, k, and b mean? Let's write down the meaning. The new origin is given by h comma k. The phase shift is your h coordinate. Your vertical shift up or down is k. Your amplitude is given by a. And know that your amplitude is a and it's up or down, up and down from the center, from the new origin. Your period is given by 2 pi over b, and it goes horizontally, okay, from the origin. Your frequency, which is period per unit time, is b over 2 pi, or the reciprocal of your period. So b over 2 pi, which is the same thing as 1 over your period. All right. So these are the pieces of information that can help us to generate a perfect sine and cosine graph. All right. All right. So let's go ahead and start with question number 1. Graph y equals sine x on the interval negative 2 pi is less than or equal to x, and x is less than or equal to 2 pi. Okay, this is a periodic function that continues forever, but we're going to restrict our graph or our domain to these values. Okay, so what we're going to do first, we're going to express this function in transformational form. So we're going to have y minus 0 equals 1 sine bracket 1 times x minus 0, like that. Okay, so there goes your sine function in transformational form. All right, so now what is the new origin or the new center? The new origin is still the original origin, which is 0, 0. There's no transformations here. Later on, when we're doing more advanced problems, you see the power of this formulation. Okay, so new origin is 0, 0. Your phase shift is the movement side to side. There's no movement side to side because x is still 0, so there is none. The vertical shift is a movement up or down. Is 0. There's no movement up or down, so there are no shifts up or down. Remember, the x coordinate is side to side, and your y coordinate is up and down. This is your phase shift. This is your vertical shift. Okay. All right. Your amplitude is the coefficient of sine. Amplitude in front of sine we have 1. Okay. So amplitude a technically is absolute value of a is equal to 1. All right, because the sign doesn't really matter. All right, your period. a period, if you look at this problem, your period is 2 pi over b, and we know that b is a number right here. You can indicate that this is k, a, b, and this is h. All right, so b is 1. So our period is going to be 2 pi over 1. 2 pi over 1 is just 2 pi. So when we're graphing, this tells me that I'm going to calibrate as follows. 4 ticks. 4 ticks or 4 quadrants is going to be equal to 2 pi. Okay, that's my method of calibrating my horizontal axis. All right, so let's keep that in mind. All right, what is our frequency? Our frequency is the reciprocal of the period, which is b over 2 pi. B over 2 pi is 1 over 2 pi. Okay? Alright, now the last thing I'm going to put here is a window. It basically tells me how to set up my coordinate system so that my graph fits in perfectly. Okay? So to generate my window, I'm going to put the new origin in the center, which is 0, comma, 0. Alright? Now, I'm going to go up and down by the measure of the amplitude. So my amplitude is 1, right? So I'm going to go up plus 1 and then go down minus 1. Okay? So if I go up, if I add 1 to 0, my graph is going to go as high as 0 plus 1, which is 1. How low does it go? As low as 0 minus 1, which is negative 1. So when I'm calibrating my y-axis, I need to go as high as 1 or as low as negative 1, and that'll be sufficient. Okay? How about the horizontal span of my graph? Well, I need to look at my period. Okay? For this problem, we're asked to go from negative 2 pi to 2 pi. So let's make sure that this period vertical span we have here covers that situation. Okay? So 2 pi, I'm going to graph 2 pi to the right. So plus 2 pi to the right, and then to the left, minus 2 pi. Okay? That's one period to the right and one period to the left. Let's see what happens. So if I add 0 plus 2 pi, I have 2 pi on the right, and then to the left, negative 2 pi. This is excellent because that is the domain that we're asked to graph on. Alright, so there goes our window that we're going to use to generate our graph. Let me box it so you don't get it confused with my frequency. Alright, so there goes the window. Alright, let's go ahead and calibrate our axis with this window in mind. So it's centered around the origin, so that is fine, it's not skewed in any direction. Let's do our x and y coordinate. Now, how do we calibrate our x coordinate? We said it earlier that 4 tick marks should be 2 pi, so let's use 2 tick marks, 2 boxes for a tick here. So this is 1 tick mark, 1, 2, 3, 4. That represents a complete cycle or circle, 4 quadrants. So that's going to be 2 pi because that's the width of our period. Okay, so going back the other side, 1, 2, 3, 4. All right, and that's negative 2 pi. The calibration of the y-axis, you notice that we're going by the amplitude here is just a number, so we're going to go by numbers. Let's use 1, 2, 3. Let's use 3 boxes for a 1. And then going down 1, 2, 3, 3 boxes, negative 1. Alright? So you see our window says to go from negative 2 pi to 2 pi, and then from 1 to negative 1. That's sufficient. Alright? Now, what we're going to do is this include our boundaries. Okay? Our maximum is going to be how high we go, which is 1. So that goes our maximum from the center. And then our minimum is how low we go, which is negative 1. There goes our minimum. Okay, so our graph doesn't go beyond higher than this, it doesn't go lower than this, and this is the middle. Alright, now we're going to put in the points for a sine function. Remember that your sine function, sine y equals sine x, is like an S. Okay, one complete period is like an S. Alright, and for a cosine, one complete period is like a cup. Alright, so let's keep these configurations in mind when we're graphing this. Alright, so let's go ahead and graph the sine. So sine, you start from the center. So like the S, you're going to go Center, one tick mark to the top, one tick mark back to the center, one tick mark to the bottom, one tick mark back to the center. All right? Then going in the right other direction, one tick mark from the center, you're going to go to the minimum, one tick mark back to the center, one tick mark to the max, and one tick mark back to the center. Okay? Let's indicate our boundaries. This is our maximum, and this is our minimum. All right, we're going to connect dots to generate a graph of our sine function, and that'll be that. All right? So when you're going out of the center, the slope is 1. So we have to, and it's very straight, so it goes straight out the center, curve out the max, because the slope is 0, and then curve out of the max, straight in towards the center, straight out the center, curve out the min, because the slope at the minimum is 0, curve out the min, straight towards the center, okay? And then straight out the center, curve out the min, curve out the min, straight towards the center, straight through the center, and then we curve out the max, and then curve out the max, and then straight to the center. So we're going from 2 pi to negative 2 pi, and we had a solid line here in our boundaries. There's a question. We had solid lines here in our boundaries. That means we're going to go make this a closed circle because we stop here, and make that a closed circle also. If we were not given boundaries, this pattern will here goes the graph of y equals sine x. Okay? Alright, now let's go ahead and sketch the graph of the other trig function, number 2. Alright, how about one graph y equals cosine x on the interval negative 2 pi is less than y, and y is less than 2 pi. Okay? We're going one period to the left, one period to the right, but the endpoints are not included. So let's see this. So I'm going to write the transformational form first, and then we'll use that to generate relevant information. So the transformational form of this is y minus 0, because there's nothing subtracted from 0, equals 1, the coefficient of cosine, bracket 1, parenthesis x minus 0. Alright? Because there's nothing being subtracted from the 0 here. Alright, so there goes the transformational form. That tells me that the new origin is 0, 0. Okay, this information tells me the phase and vertical shift. Okay, the phase shift is the x-coordinate. There's no movement on the x, is always 0, right? So that means your phase shift is none. Your vertical shift is your y-coordinate. There are no movement there because it says 0, so it's none. Now the next thing is your amplitude. Amplitude is the coefficient of cosine. Your amplitude is 1. Okay, because that's what the value of a is, so you're going to be going up and down 1 unit. Now your period. Remember the formula for period? Period is 2 pi over b. In this case, b is 1, so we're going to, because that's the b right there, let's indicate it so don't get confused. This is a, this is b, this is h, and that's k. Okay? Alright, now 2 pi over b is basically 2 pi over 1. 2 pi over 1 is just 2 pi. And this tells me that 4 ticks is going to be 2 pi. Okay? 4 ticks or 4 quadrants would give me 2 pi. And that's going to be my horizontal calibration. Alright, we have the period. Next thing we need is the frequency. The frequency is the reciprocal of the period, b over 2 pi, or 1 over 2 pi, and there you have it. Okay. Now to set up the window so that we graph our graphs correctly, let's go ahead and set up the window real quick. Now the center, or the new origin, is 0, 0. So we're going to go up and down the value, along the y, the value of the amplitude. Amplitude in this case is 1, so plus 1, minus 1 along the y. So if I'm going to go as high, my maximum is going to be 1, and my minimum is going to be negative 1. Okay? Side to side, what is our horizontal span? We're going to look at the period. The period is 2 pi, so I'm going to add 2 pi to the right and subtract 2 pi to the left. Okay? Because that's the value of the period. 0 plus 2 pi is 2 pi, and then minus negative 2 pi. So this calibration, this window is just for one period to the left and one period to the right, okay? And it basically captures what we were asked to do based on the intervals that we were provided with in the original question. In the original question, we were asked to go on our x from, let's look at it, from negative 2 pi to 2 pi, and this basically is sufficient for that. All right, let's go ahead and sketch the graph. I'll make a coordinate system right down the center. All right, now when we're calibrating our x-axis, we talked about this earlier, 4 tick marks should be a period. So 4 tick marks should be 2 pi, which is a period. So we're going to go 1, 2, 3, 4. That's one complete period, 2 pi. And then 1, 2, 3, 4, and that's negative 2 pi. Okay? Calibration done for the x. Up and down, let's use 3 tick marks for a unit. So we're going by units here. 1, and down by units. How do we know we're going by units? Because our amplitude, A, is a unit, which is 1. Alright? So there we have it. Okay, so what we have it calibrated. So we have our max. Let's do our max. Like that. And our minimum, like that. Okay, now let's go ahead and graph the function. Remember the orientation of our curves, right? Y equals sine x. Sine x is like the S. One period is like an S, like that. And the cosine, remember, is like a cup. Okay, C for cup. So one period of the cosine. Let me take that out. I don't like that. One period of the cosine is something like this. It's just like a cup. Alright, so this is the configuration we're going to use when putting in our points. Alright, so we know that this is our maximum displacement from the central position, and this is our minimum displacement. So what we're going to do is we're going to put in the points. Okay, so we're going to go center. Actually, I'm sorry. Cosine is a cup, so we're going to be starting from the top. Okay, I'm going to label my axis. This is y, and this is x. So we're going to be starting from the top, so let's put in the point. We have a point on the top, that's a maximum. Maximum, 1 tick mark center, 1 tick mark minimum, 1 tick mark center, 1 tick mark back to the max. Same thing to the left, maximum, 1 tick mark center, 1 tick mark minimum, 1 tick mark back to the center, 1 tick mark maximum. Okay, and then we're going to connect our curves, our points. We're going to curve out out of the max because the slope at the max is 0. Curve out of the max straight towards the center, straight out the center, curve at the min, curve out the min, and then straight to the center. Okay, and then straight out the center, curve at the max, like that. All right, and then here, curve out the max, and then straight through the center, straight out the center, curve at the min, curve out of the min, straight to the center, straight out the center, and then you curve at the max. Okay, so there goes your cosine curve right there. All right, now since the endpoints are excluded, we have to use open circles at the endpoints. Open circles at the endpoints. So this is going to be an open circle here. Close that, and then this is going to be an open circle. How did I know that it's open circle? Well, let's go back up here. These lines right here basically means open circle, open circle. Okay, like in number 1 we had closed circle, but this one is open circle at the endpoints. Okay, So there you have it.